Hello everyone, my name is Banthiya and today we are going to study organic chemistry. Organic chemistry is not only a branch of chemistry but it's very important for our day-to-day being as well. Before we begin, let's first understand the history of organic chemistry. In 1785, Lavoisier classified substances into organic and inorganic things. That is, the things which were originated from vegetable and animal were called organic substances, and the things which are already present in the atmosphere or on the earth, like metals, non-metals, minerals, etc., were classified into inorganic materials. In 1800, Vesalius stated vital force theory. He said that to produce an organic compound, we need a very vital force, that is, a life force is required, which means that up till 1800, we were unable to synthesize organic compounds in laboratory. But in 1828, Mr. Frederick Holler proved this theory, that is vital force theory, wrong by synthesizing urea from ammonium cyanide. And we all know where we can obtain urea from. So this is about the history of organic chemistry. And post that, many more organic compounds were able to be synthesized in laboratory. And we use many of the products in our day-to-day lives nowadays. So what is organic chemistry? Yes, we all know that it's the study of compounds which contains carbon. But is every compound which contains carbon classified into organic chemistry? No. So, except for carbides, oxides of carbon, carbonate and hydrogen carbonate salts, every other thing, every other compound that we study which contains carbon is classified under organic chemistry. Yes, carbon as an element is not an organic compound because it's not a compound in the first place. Carbon is a non-metal that we all know, and carbon being a non-metal forming covalent compounds is a very bad conductor of electricity. But there's an exception. Exception is the graphite. The reasons are the hybridization that it displays, but that's not the scope of study today. Their melting point and boiling points are relatively low when compared to ionic compounds. Yes, this is a very important characteristic of inorganic compounds. Inorganic compounds usually can be made into ionic compounds, and hence they have pretty much higher melting point and boiling point because the intermolecular forces of attraction that they have are pretty much high as compared to organic compounds, which are made from covalent compounds. Organic chemistry is the chemistry of specific carbon compounds. Now, in this presentation today, we are gonna talk about hydrocarbons. Hydrocarbons, as the name itself denotes, is an organic compound which contains carbon and hydrogen only. For example, methane, ethane, propane, butane, butane, etc. Natural sources of organic compounds are huge. We get carbohydrates and acids from plants. Many organic acids we get from plants. The source of protein and urea is animals. And from coal we can produce dyes and drugs. Importance of organic compound is in every single aspect of our life. Food, shelter and clothing. All the three things are incomplete unless and until an organic compound is used. First of all, before we get in depth about what are organic compounds and how are they formed, we will see what's the difference between organic and inorganic compounds. So first, organic compounds. Organic compounds are the compounds which have composition. The composition consists of few elements. There are total 118 elements in the modern periodic table that we all know, but very few elements are there present in organic compounds, which are listed in the presentation. And in inorganic compound, we study all the elements that are in the modern periodic table. Nature of organic compounds is that they form a covalent bond. The melting point and boiling points are low as compared to ionic compounds or inorganic compounds. The solubility in water is negligible, but their solubility in organic compounds is high. They are basically non-conductors of electricity and they are combustible and volatile. What do we understand by volatility? Volatility is the ease with which a particular substance gets evaporated. Catenation and isomerism is exhibited by organic compounds. Whereas the properties of inorganic compounds are given in the presentation. The first property is the nature of the compound. The nature of the compound in inorganic compounds is electrovalent, that they form ionic bonds or electrovalent bonds. The melting point and boiling point is relatively high. They are soluble in water, but most of them are insoluble in organic solvents. They are usually good conductors of electricity, and they are non-combustible and non-volatile. The property of catenation and isomerism is not exhibited by inorganic compound. And please note here that these are general properties. There are exceptions for both the things in case of organic compounds as well as inorganic compounds. This is a general outline. So there are more than 5 million organic compounds that we know today. And every year we get to know a couple of hundreds more. So organic chemistry is a very important part of chemistry. Chemistry of carbon compounds is organic chemistry. Carbon is a very unique element. As we all know, carbon has a tetravalency. That is, it has only 4 electrons present in outermost shell, and hence it can neither give or receive electrons. It can only share electrons. And why is that? Carbon has 4 electrons in its outermost shell. That is, it has in total 6 electrons. That means it has 6 protons. When an atom has 6 protons, it is capable of holding 6 electrons. But when it accepts 4 more electrons, if in case it does, it becomes unstable because those 6 protons in the nucleus of carbon atom are unable to hold the additional 4 electrons that it might have gained. In case it has to give away 4 electrons, there is a huge amount of energy that is required, and hence carbon neither gains nor gives electrons, and hence it shares electrons. It forms 4 covalent bonds. As we can see in the figure that each carbon atom has 4 electrons in the outermost shell, which is represented with a black dot. And a hydrogen atom, as we all know, has only 1 electron in its outermost shell. And to complete its duplet, it needs 2 electrons. And for carbon, it needs an octet. So, they share those electrons as shown in the diagram and form covalent bonds. These covalent bonds are represented with a simple single dash representing one covalent bond. Carbon is again unique because it shows a property of catenation. Catenation is a property of self-linking, and carbon has a maximum number, which means that n number of carbon atoms can be attached to each other, can be linked to each other, whereas silica is another element which represents the property of catenation. But it is unable to create long chains as good as carbon can. The linking can be done in various different methods, like it can form a chain in a very straight line. It can also form a branch chain or a closed chain. The open chain structure or aliphatic compounds. The straight chain compounds and the branch chain compounds are called aliphatic compounds. As shown in the image, the first one on the left side is a straight chain carbon compound and the other is branch. Now, these are the examples of closed chain where a closed loop is formed between the carbon compounds. These compounds are also called cyclic compounds formed by closed chains. While linking, two carbon elements can be attached to each other with a single covalent bond, a double covalent bond, or a triple covalent bond. That is, the number of electrons shared between two carbon compounds may vary from 1 to 2 to 3, hence forming a single bond, double bond, and triple bond, represented as shown in the images. Carbon can also form double bonds with different elements as shown in the figure 1, where with an appropriate element, such as in this case it is shared with oxygen. Oxygen has valency 2, that means it has 2 electrons less to its octet. So a double covalent bond is shared between carbon and oxygen, and similarly the valency of nitrogen is 3, and hence a triple bond can be found between carbon and nitrogen. Now, hydrocarbons. Hydrocarbons are generally classified into two, that is saturated and other is unsaturated hydrocarbon. Saturated hydrocarbons are not very reactive because they all have single covalent bonds. They all form single covalent bonds. And in unsaturated hydrocarbons, which is more reactive than saturated hydrocarbon, there is double bond or triple bond present. For now, we should see a table below which says 1 is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, 6 is hex, and so on. This is the basic nomenclature in organic chemistry and one should learn it. So, in saturated hydrocarbons, the first thing that we have to see is alkanes. In this name, alkanes, you can see that ALK is colored in blue and ANES is colored in black. ANES is the suffix that we use for alkanes, that is methane, ethane, propane, butane, and so on. In the example given below, where N represents number of carbon atoms, N equals to 1, so carbon is 1, and as we know, in saturated hydrocarbon there are only single covalent bonds. So all the 4 valencies of the carbon are satisfied using a single covalent bond with hydrogen atom. Similarly, when N becomes 2, carbon-carbon single bond is shared and other valencies are satisfied with hydrogen atom. So on, when N equals to 3, the structure is given. Now, when we see all the 3 structures, the molecular formula becomes NH4 for N equals to 1. The molecular formula becomes C2H6 when N equals to 2 and C3H8 when N equals to 3. Here we can see a pattern is formed. And so the general formula for alkanes is CnH2n plus 2. And the table that we saw previously is used as the main name which represents the number of carbon atoms present in the compound. So methane, ethane, propane, butane, pentane, hexane, and so on can be done. Now, unsaturated hydrocarbons are divided into two, that is alkenes and alkynes. Alkenes have at least one double covalent bond and alkynes have at least one triple covalent bond. In alkenes, as we have seen that there are at least one double covalent bond, N equals to 1 is not possible. Practically and in real life, we cannot find it. Carbon and hydrogen cannot form a double covalent bond as hydrogen has only one electron in the outermost shell. So, methanes are not possible. N equals to 2 is possible because carbon-carbon double bond can exist as we have already seen. N equals to 3 is also possible. And hence, when we see the molecular formulas, again there is a pattern formed. And hence, we derive general formula for alkenes, that is CnH2n. And here, the noteworthy thing is, from this general formula, we can create methane, but it does not exist. And ethene, propene, butene, and so on exist. Here, ene is the suffix used for alkenes. In alkynes, in the same way, N equals to 1 does not exist. But when N equals to 2, carbon-carbon triple bond can exist and hence the molecular formula comes C2H2. When N equals to 3, C3H4. And a general formula is derived CnH2n minus 2. Again, CH0 is nothing else but carbon. But basically here, methane is not possible. A single carbon atom exists. Ethine is possible, propine is possible, and here YNE is the suffix used for alkynes. Now, in a nutshell, to start with what we have seen today, we have seen what is organic chemistry and we have seen what hydrocarbons are. Hydrocarbons are divided into two parts, open chain or aliphatic compounds and cyclic or closed chain compounds. Open chain or aliphatic compounds are classified under two names. One is saturated and other is unsaturated. Saturated are alkanes and unsaturated are alkynes and alkenes. Please share it, like it. Please feel free to comment in the comment box below. Thank you for watching and stay tuned for more such videos. Thank you.